Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about acceleration. So what exactly is acceleration? Let's look at the following problem. So let's say that your parents, they recognize that you passed your driving test and they say, oh, congratulations, I'm going to buy you a car. You can either choose between car A and car B. Car A can go from 0 to 60 meters per second in 10 seconds. Car B can go from 0 to 60 meters per second in 2 seconds. Which one do you want? Well, some of you probably going to choose the easy option, but you should recognize that the second one is the better option. The reason why, it can change velocity in the shortest period of time. So it can change velocity in the shortest period of time. So this is the reason why, because it changes velocity at a greater rate. And that helps us with our definition of acceleration, because acceleration is equal to the change in velocity divided by the time taken. You've got to memorize this formula. So acceleration is equal to change in velocity divided by the time taken. And in symbols, we can say A represents the acceleration, V is going to represent the final velocity, U is going to represent the initial velocity. Obviously, to work out change, I do final minus initial, and T represents the time. Okay, let's do the units of each one of them. So we know that acceleration is still going to be meters per second squared. Velocity is still meters per second, and initial velocity is still meters per second, and time is going to be in seconds. Yes, so acceleration is equal to change in velocity divided by time, or V minus U divided by T. So if I write that out, you might be able to rearrange it, so I can move the T up. So A is equal to V minus U divided by T. I can bring the T upwards. AT is equal to V minus U. Make sure we can manipulate that equation, because you might be asked about rearranging the equation to solve different mathematical problems. Okay, let's scroll down. Let's have the following. Test your understanding. A car accelerates from 2 meters per second to a speed of 18 meters per second in a time of 4 seconds. What is the acceleration? So we know the formula we just looked at. Acceleration is equal to V minus U divided by T. Which one is which? So 2 is the initial, so that's U. 18 is the final, that's V. The time is therefore 4. Now we can plug it all in. Therefore, acceleration is equal to V 18 meters per second minus, it looks a bit messy, 18 meters per second minus the initial 2 meters per second divided by the time taken is going to be 4 seconds. So, in the calculator, whatever you want to do, 18 minus 2, bang, divided by 4 equals 4. Acceleration is 4. What are the units for acceleration? They are 4 meters per second squared. And that is our answer. Acceleration is equal to 4 meters per second squared. Simple stuff, guys. Make sure you can do that yourself. Let's try another one. Well, no, let's look at an advanced equation now. So, we have a new equation, which is a bit more advanced, and it's got some variables which are squared in it. So it looks a bit complicated at the start, but it's still the same thing. We still know that A is going to be the acceleration. U is going to be the initial velocity. We also know that V is going to be the final velocity. The only new thing which you now have is going to be S, which stands for the displacement. And let's do the units of them. Acceleration we know is meters per second squared. Initial velocity, meters per second. Final velocity, meters per second. Displacement, its length, it's meters. So now we have a new formula. Right, let's test our understanding about using this new formula. Let's go. Test your understanding. A dog accelerates from rest at a constant rate. He reaches a final speed of 15 meters per second, and the distance he travels is 150 meters. Calculate the acceleration. So you're meant to calculate the acceleration, so we've got to rearrange that formula to make A the subject. So V squared minus U squared is equal to 2AS. I want the A by itself. I simply take the 2 and the S underneath. v squared minus u squared all over 2s is equal to a. That's my rearranging. So we know that a is equal to v squared minus u squared all over 2s. Now let's plug them all in. V squared, what is the final speed? So the final speed, it's here. This is v. The initial speed, it's at rest. So therefore the initial speed is 0. So let's put them in. 15 squared, yes, minus 0 squared, divided by 2 times by the displacement 150. Into a calculator we go. 15 squared, yes, divided by 2 times by 150, close bracket, I'm getting 0.75. 0.75 meters per second squared. Don't forget the units when you're working out the acceleration. Easy stuff. Now, let's finish off. Summary. Acceleration is the rate of change of velocity. So it's how fast your velocity is changing, the rate of it. Rate usually means with respect to time. Acceleration is equal to v minus u divided by t. Acceleration is measured in meters per second squared. Initial velocity is measured in meters per second. Final velocity is meters per second. And time is measured in seconds. And we have the advanced formula of v squared is equal to v squared minus u squared is equal to 2as. That's the advanced equation which we have to use as well and manipulate. Make sure as well if you're asked to rearrange it to make v the subject, you have to square root the thing here. And s represents the displacement measured in meters. So it's displacement measured in meters. And that's it for today's session. I hope you enjoyed it. Goodbye.